Morning. Till now, we have discussed about the different types of optical amplifiers, that are erbium doped fiber amplifier, semiconductor optical amplifier, Raman amplifier. So next, we are going to discuss about the thulium doped fiber amplifiers, that's TDFA. It's also a doped fiber amplifier category. It's a type of amplifier under the doped fiber amplifiers. So here, erbium is replaced by the material thulium. It is pumped around 1047 or 1400 nanometer. It can be used for amplification in the S band around 1460 to 1530 nanometer. So I think you know the different bands. It can be used for amplification in the S band. Okay, that is the important thing here. And combined thulium erbium fiber amplifiers thus provide optical amplifiers in very wide wavelength range. Can use the amplification in a wide wavelength range if you are combining the thulium erbium fiber amplifiers. So that's why this is thulium and the fiber amplifier. The basic architecture used to model the TDFA or thulium topped fiber amplifier in the WDM wavelength division multiplexing system consists of. So WDM we will discuss in detail in the next session. That means in the next module. Here, the basic structure that are used to model a TDFA is the 16 input signals, that is the 16 input signal channels are there, and an ideal multiplexer and a pump laser and a thulium doped fiber, that is important active medium, that is an active medium in the amplifier, the optical amplifier, that is thulium doped fiber. And after that, optical spectrum analyzer and all for WDM analyzer. These are the basic architecture that's used to model TDFA. The power of each channel is minus 20 dBm, and the TDF is used as a glass-based one with thulium density of 1.5 in 10 raised to minus 24 meters square. There's a density actually. How much it is doped, we can understand from that. 1.5 in 10 raised to minus 24 meters square. That is the thulium density in that glass paper. Core radius is 1.3 micrometer, and doping radius is 1.3 micrometer, and the numerical aperture range, that is 0.3. These are the important things regarding the thulium doped fiber amplifier. That's enough in this case. The important amplifiers you have to study in this module are LPN doped fiber amplifiers and semiconductor amplifiers, common amplifier. Okay. TDFA is not so much important. So just mentioning about the extension or by the changing of their PM into thulium, what are the advantages and what is its specification, what is important things here. Then we have to compare the performance comparison of the various optical amplifier that we have discussed here earlier. That is EDFA, Raman amplifier, and semiconductor optical amplifier. These are the important amplifiers. So we have to compare its performance. So the gain of these amplifiers, the gain is very good, very high. Is more gain. We can get the more gain in EDFA, that's greater than 40, and in case of Raman amplifier, that is greater than 25, and semiconductor optical amplifier greater than 30. So EDFA offer more gain than SOA, and SOA offer more gain than Raman amplifier. The wavelength of operation, so the wavelength that is EDFA is 1530 to 1560. That is the wavelength range of the EDFA amplifier. And in case of Raman amplifier and SOA amplifier, that the range is same, that is 1280 to 1650. Okay. The bandwidth is 30 to 60 is the dB bandwidth that's providing EDFA. And in case of semiconductor optical amplifier, that is 60. That's 60, the maximum, that is 60. But that offering the bandwidth up to 60 dB. 60 bandwidth in 3 dB. So 3 dB bandwidth, that is here getting that 60. And in case of Raman amplifier, the pump dependent, the bandwidth is pump dependent. We can specify, we can say some value be pump dependent. And maximum dB in dB and SOA is the migration 18, and in case of Raman amplifier is 0.5 7 that above, whatever that amount, multiply 0.75. Okay. And comparison sensitivity is not in the case of TDFA and the Raman amplifier, percent in the case of that is yes in case of semiconductor optical amplifier, and noise is in case of semiconductor optical amplifier, that is key. And as compared to semiconductor optical amplifiers, noise is less than 5 in 5 dB in case of TDFA and Raman amplifier. From of TDFA is 25 dBm in case of Raman. Okay. And in case of semiconductor optical amplifier, uh, we can say that the size of the amplifier, size of amplifier is rack mounted and bulk mounted and compact. In case of IDFA, it is rack mounted. In case of Raman amplifier, it is bulk module, and silicon optical amplifier, that is compact. Okay. And switchability cost factor is very high in case of Raman amplifier, and it is low in case of silicon optical amplifier, and a medium in case of EDFA. These are about the performance comparison of the various optical amplifiers that are EDFA, Raman, and SOS optical amplifier.